Hello everyone, February the 14th. Alright, let's do this. Alright, find polygon with the largest parameter. You're given an array of positive integers nums of length n. A polygon is a closed plane figure that has at least 3 sides. The longest side of a polygon is smaller than the sum of its other sides. Correct. Conversely, if you have k positive real numbers where blah blah blah, and yes, then there always exists one polygon with k sides whose lengths are, that is correct. The parameter of a polygon is a sum of lengths of its sides. Return the largest possible parameter of a polygon whose sides can be formed from nums, or -1 if it is not possible. So the first one is 3, so you have 15. And the second one is very interesting. Okay, so the first example is not interesting. The second one is interesting, and most likely we need to sort it. 1, 1, 2, 3, 5, 12, and 50, right? So what we're saying is, if we have the sum of these, if this is larger than this, then this can form a polygon. Then we'll be right? So we add them together, and it doesn't work, right? It doesn't work. So we will try add these together and see if it's larger than this, right? So whenever the first time it works, that will be the polygon. That's actually not quite true. That's not quite true, because it might happen that no, it is true. It is true, because if, let's say, because you're doing the scheme, right? You try to find, and if you say that some other can form a polygon, then we're adding this would definitely form a polygon. So this problem becomes very straightforward. All we need to do is to find the prefix sum, okay, of the entire thing. And now we start from this, trying to compare with this, right? If it's no good, we move on to here to compare with this. And we don't have to consider this, because if this added together cannot be larger than this cannot be larger than this. So we do this, we try to compare this, and then once it works, so the answer will be one of these values, right? One of these values will be the answer. So I can just do this to compare with this, right? And this to compare with this. Whenever it works, this will be the result. Okay, so we need to do a prefix sum. Let us do a prefix sum. Do you think you can do a prefix sum? I might need to, you know what, I'm gonna do this. I'm going to do this in place. I don't care, I just want to do it in place. Is it the best way to do it? Probably not, but I want to do it in place. Because yesterday I want to do it in place and it didn't work, so I want to do it in place today. Okay, how are you gonna do it in place? We basically set for int I 1, I smaller than nums.len, I plus plus, right? And oh, can we do a 1 pass? We probably can, if I can do int rest is equal to 0. Okay, so we have to do here, we say nums I shall equal to, shall plus equal to nums I minus 1, right? And if I is larger than, because you had the other one, larger equal to 2, okay, then we say if it's larger equal to 2, actually we should set this to -1, right? If it's larger, ooh, when you sort it, arrays dot sort nums, right? And if I is larger equal to 2, then we can say if I larger equal to 2 and, right, and nums I minus 1, this is actually the prefix sum, right? If that is larger than nums I minus nums I minus 1, right? If that's true, then res equal to math.max res and nums I. And then we keep doing this, and then we'll return res at the end. All right, let's give this a shot. Throw everybody in, and we have a correct answer. Okay, let's just write it. I think this is correct. 2971. Prefix sum. Sort the array, and then prefix sum. All right, let's give this a shot. Oh, it's a new problem. Oh no, that was not right. Holy crap. I think maybe it's overflow. Damn, it may be overflow. Oh yeah, it's a long. Shoot. Shoot. Why don't you tell me? Right? Why did you not tell me that? Oh, holy. Okay. All right. See, this is why I don't like this, but okay, that's fine. I need a long pre. Okay. Pre equals nums 0. I need a current. Yeah, I have a pre, and I need a current. Long current. Doesn't matter what current is. Now we say current will equal to pre plus long nums I, right? So we have the current, and we don't do this. We say this, and this will be pre, right? If pre is larger than current minus pre. Actually, I don't even need this because I didn't really change nums, so I can do nums I, right? If pre is larger, so I don't even need the current at the moment, right? I can just do, if pre is larger than this, then res will equal to, you know what? Hold on. Current, right? And this will be current, and then at the end pre equal to current. All right. That was mainly just oversight of. Okay, let's try this again. Yep. So this will be time and 01 space. All right, let's run this. All right, let's see. That's prefix on sorting. Yep. Oh, I don't have to do the max call because always getting bigger. Holy crap, it is true. Then I just need to do if pre is larger than But what if, oh, did they say at least we have 3? Oh, I already said at least have 3. Oh, we did a lot of useless check. Right? We did a lot of useless check, which means I do this. I don't need current. I don't need this. I can just say int num, int n of nums, right? And then we have the pre. We handle pre later. We just say if larger than n, right? Res equal to pre, and then pre will be plus equal to n. That is not right. Oh, because I start from I set pre to 0. That is not right. Wait, I don't know. Actually, no. It should be pre plus n, right? It should be pre plus n. Then we do this. There we go. This is right. That's the same. Anyway, this is easier. Alright, so we're done with this. Good. That was good, unless they have another solution. I don't think they have another solution. Alright, so we're gonna try this concise solution. Stepping numbers. Alright, so stepping numbers. Let's do this. The stepping numbers. Stepping numbers. I think I still remember how this one goes. Yeah, I have a complicated solution, and right now I want to entertain. Oh, look at this solution. It's so complicated. Now I want to entertain a better one. Alright, so we say this one, this solution is inspired by the ideal is to use a DP call to find the total number of stepping, total count of stepping numbers from is to use is to set, right, dpn to be the count of stepping numbers, right? Stepping numbers from 0, right, from 0 to n. And once we get this done, the answer is as simple as dp high, right, minus dp low minus 1. Right, okay, so that's that. Alright, so how do you find this? Def we do dp, right? So when we do dp, we given the thing, right? We given the thing, which is you know, the number, right? We do the number, and once you give the number, we'll say, we'll have the index, right? So we say from this index, from this position going to the end, right? From this position going to the end. How many, right? How many are, so when we have the number, and we're gonna have the index. Okay, so index, and number is tr, right? So we say from this, you need to give me an integer to tell me how many there are. So we start from the current index, right? And then how many we can try, right? How many we can try. That depends on what. So I can try all those and then go to the next one. So I do need to know the previous value. Right? I need to know the previous value. And the previous value will determine if the current one is valid or not, right? So basically we look previous. So I'm at my current index, right? And I look at my previous value, and then if it's good, okay, so basically I think I need a previous value. So it's a pre-digit, okay, as an integer. So first of all, if I go through the whole thing, right, index just keep moving on. So I basically start from this index towards the end with this pre-digit, how many I get, right? I start from this towards the end with this pre-digit, how many I get. That is basically what we want to do. And once we get to the end, basically we say if, index is equal to len str, that will return 1, right? Do I have value cache? I think I do. Right. So basically I say, right, if I can handle the entire thing without any issue, then yeah, definitely we have return 1, right? That's 1 count. Otherwise, for the current index, right, based on the previous digit. Now this previous digit is, and I'm going to set to -1 when we first start. Okay, that was inspired. So if it's -1, that means I don't have anything previously. Then I can do whatever I want, right? But then I also need to know, yeah, based on the previous digit, if I can do whatever I want, or I cannot do whatever I want. So let's just handle this if now pre-digit is equal to -1. Okay, if a previous digit is -1, which means I'm starting fresh, right? I'm starting fresh. So if I'm starting fresh, I can choose to I can always choose to start fresh at every single digit, right? So I shall say res equal to dp index +1 and str and -1, right? We can always choose not to start from the current index. Yeah, this is a very important concept. This is just like a knapsack, right? It's like a knapsack, because we can say, hey, I just don't want to start from the current, right? We can always choose not to start from the current. We just delay it later. Otherwise, then we have to start with the current. Then if the previous digit is 1, that means I can do whatever I want up into the current. Then we say for current digit in range, basically it's going to be from 0 all the way to nstr index, right? So this is like my hard limit, right? So for all of those, I can choose any one of them, right? I can choose any one of them because we don't go above, right? We don't go above. So we pick one, then we go to the next one, right? Then we go to the next one. Then I say res plus equal to dp index plus 1 and str and current digit for the next one, right? Done. Else, if the pre-digit is not a -1, so it is actually a value, then it depends on what I am going to be, right? So the previous digit, I have a certain digit that's previously. Now it come to me, right? Now it come to me. But then what I need to know is when it comes to me, what I need to know is if it's a tight one. Yeah, you have to use a tight, right? If it's tight, okay, if it's tight. So I need to know if it's tight, or how should I say, because if it's tight, then I cannot go above whatever the current digit is. But if it's not tight, I mean, depending on the previous one, right? If it's not tight, then I can always go beyond, right? I can always go beyond. I can always go beyond. Then what do you need a pre-digit for? Well, I need a pre-digit, right, to say the current one is either +1 or -1, right? Yeah, +1 or -1, and I need to know if I can do +1 or -1. And that depends on whether it's tight or not tight, right? So is tight, it's a Boolean value. Okay. If is tight is true, that means the current, the choice of the current digit, cannot exceed nstr index. Otherwise, we can choose any digit from 0 to 9. Right, so in this case, that will always be true, right? Because you start from here. Wait, is it true though, right? What we're trying to see is if I ditch it, it's smaller, but this will always be false, okay? This will always be false because you have smaller number of digits than the current, right? Than the current, because we always just want to be smaller. So you can always choose whatever you want, right? Whatever you want. And it's true that if your pre-digit is -1, you can always choose whatever you want. It is when your current digit is, or your pre-digit is not -1, right? In that case, then it depends on, so the current availability is the pre-digit +1 or the pre-digit -1, right? Pre-digit -1. And we can say two options, right? So option 1 +1, right? So we can say current digit can equal to pre-digit +1. And then we say if, if pre-digit is smaller than 9, right? Then I can do current digit equal to this. And if the current, and if it's if it's not tight, right? If the previous is not tight, that means I can choose whatever. So it will always be not tight, right? It will always be not tight. But hold a second, how about here? Well, this is predigits -1, right? And then I cannot go above. So whatever I choose, oh, it depends, right? So these are not reaching, which means all of them are false. They're not tight. But I can also do dp index +1 and str current. No, it's int and str index. Now that is going to be tight, right? Because I can pick the same as whatever it is. I can pick that. I can pick that. And if I pick that, then it becomes true. Hold on, is that correct? Predigits -1. So we start. No, it's if predigit is -1, right? And we say, yeah, if predigit is -1, that means we have no limitation. We have no limitation. Come on, we don't have any limitation on this. It's only like, it doesn't really matter, right? If the because I have predigits -1, so we have a smaller number of digits. It always works. Therefore, what I need to do, like, why do you even need to have, it's only when index is equal to 0, right? If predigit is -1, right, and the index is 0, so we're looking at the first one. But if predigit is -1, but we'll start looking at the second one, that will always work, right? It will always work. That's why predigit, that's what this one's doing, right? That's what this one, just move on, and then we do this, and then move on, we do this, and move on, we keep moving on, right? Starting from this as the start. And then we consider the current, right? We consider the current. And then if this is -1 and depends, right? Depends, we say if index is equal to 0, then we have a tight, right? We have a tight. We say if index is equal to 0, then we do this, right? These are non-tight. These are non-tight, right? These are non-tight because, yeah, they're just not tight. A current digit in these, yeah, they're not tight, so it'll be false. But this will be tight, right? This will be tight. But else predigit is -1, and index is not equal to 0. So we already have, we basically say how many stepping numbers, right, with this number of digits, with this number of digits. So in that case, I can just do for current digit in range int and str index. We can even do +1. Oh, monitor? This is a, dude, that's a good question. What monitor is it? Dell. Or is it Dell? Yeah, I think it's a Dell. I don't remember. A very standard monitor, I think. Dell. Oh, I actually know. Hold on. I think I know how to find out my monitor information. I think it's this one. Top screen. Nope, that's not the one. Bottom screen. Dell U2722DE. I have no idea. It's Dell. Let me Google this one. Actually, I'm not sure what. Hold on. So it's this one. Del U2722D. Yeah, I think this is the one. Either this one or this one, which is 24. I think it's 24 inches. Yeah, I think it's 24 inches. All right, let's get back. Where was I? We said index is not equal to 0. Index is not equal to 0, so I can go, and it's -1, right? The pre-index is -1, which means I can go whatever I want. So I can do all of this, right? I can do all from 0 to that, right? I can go 0 to that. I can no, actually this is not true. This is not true. I can go literally everything, right? I can go everything. I can go to 10 from 0 to 9 because I go 0. Oh, can you go 0 to 9 though? You probably have to go from 1 to 9 because you don't have leading 0 because the previous is -1. So then right now it's you have leading 0, which means I need to go from 1. And in this case, it's the same. I think you should go from 1. You cannot go from 0 because there's no previous digit, right? You go from 0, basically it's this case, right? You go from 0. So you go from 1 to 10, and I say rest plus equal to dp index plus 1. Everything is the same, current digit, and what is this? This will be false. It's not tight, right? It's not tight because you have a smaller number of digits. Okay. So that's that. And then I say if pre-digit is not equal to -1, then we have a pre-digit, right? We have a pre-digit. Then if the pre-digit is smaller than 9, then the current digit I can -1 because we want to make it, right? We want to make it stepping. So will be +1. And once we +1, then we need to check, right? We need to check. How do we check? What do we check? We check whether it's tight, right? Whether it's tight. A tight means we cannot go above. If it's not tight, then we don't really care, right? If it's not tight, we don't really care. Then we check, we say if not is tight, right? If it's not tight, or if it's not tight means I can use the current digit, or if it's tight, right? If it's tight, that means the current digit has to be smaller. So or current digit is smaller equal to int and str index, right? So when these two is working, then I can say rest plus equal to dp index plus 1 and str current digit. Is this tight or not? Depends on whether current digit is equal to int and str index. I did a lot of this thing, so I probably, all right, I can say n digit, digit of n, okay, digit n equal to str index. So then I can say, I mean, look for this int and str index this. Ooh, what the hell? I have to do this? Wow, I did not know that. Okay. Oh, I have to do this one anyway. So I will do digit n. Okay, so next one, I think it's a dot. Yeah, next dot, next dot. All right, so if it's smaller than this, then whether it's tight or not is depending on this, right? If it's equal, then it's tight. Okay, so that's that. But if it's if it's tight and it's larger than, then we cannot use it, right? We cannot use it because we cannot be bigger. So that's that, and we say option 2, right? Option 2 -1, right? So if if pre-digit is larger than 0, And current digit. I never really see a 0. Pre-digit -1. If not is tight. No, it will always work because it becomes smaller, so it doesn't really matter. So we can just go rest plus equal to dp index +1 and str current digit. It will always be false because I am getting smaller. So if the previous is a tight one, right? If the previous is tight, and now I am smaller, so it will no longer be tight. Or the previous, no matter what, it will be like this. Okay, so we'll do that, right? We'll do that, and then at the end we'll return result. Then we will return dp index is 0. We do high and pre-digits -1 is tight is true, because when we start, the tight is true, right? The tight is true. The tight is true. Okay, and then I say minus dp 0 int str int low -1 and -1, and it will be true as well. So his start is always true. And I don't need to check for index equals to 0. I just need to check for is tight, right? If it's tight, then yeah, because the 0 will always be tight. Yeah, I should be able to check if it's tight. But that's actually not true, because if you have smaller number of digits, you don't really care about the tight, because nothing is tight, right? Nothing is tight. You can do whatever you want, right? You can do whatever you want, like with the current start. Okay, so it'll be like this and mod. All right, let's see. Mod is not defined. Okay, we'll not defined. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoosh. Let's take a look. 44. You think it's gonna be right? I don't know, man. I have no clue. Let's take a look. That is bad. That's very bad. Very, very bad. Output 14. What the hell? 14. Jesus, man. That is bad. Okay. Yeah, that's fine. I mean, I'd expected this to be a little bit, because I'm deviating from whatever was written in the official solution. I'm deviating. Okay, I'm deviating. I just need to know what did I do wrong. For one, I probably need to check how many is. I can do this. I'm gonna say print dp 0 high -1 true. Just take a look, see how this one goes. I got 48. Do you believe that? 48. All the way to 90. Well, whether you believe it or not, 48. You know what? I think I have a better one. This is easier. Because 12, it's 1, 2, 3, 4. 1 to 10. Right? 10 should be 11. Right? There should be 11. I got 4. That is bonkers. Oh, high. We do high. No. Let's do low. Okay, let's do low. It'll be easier. 13. Nah, that's not right. I don't think it's 13. I don't think it's 13. Okay. Let's handle it. It's not 13 because 1 through 10, that's 10. 11 doesn't count. And then it's 12. That should be 11. Right? That should be 11. Okay, what went wrong? Alright, of course, I do 0, low, -1, true, so it comes in. You can always choose not to start from the current index, so you go to the next one. You know what? There's actually an even better. We can try, we can just try, right? We can just try. Let's say I do 1, right? We can just see if it works. That's 2. That is not right, right? That is not right because I think I'm counting 0. Because when I put 1 in, right? I put 1 in, I do index plus 1, then boom, I get 1. Okay, right? I get 1. And then if I don't do, then I say the digit right now is 1. Okay, the digit right now is 1. And then pre-digit is -1. Then I go index is 0. The current digit should be from 1 to 1. There's nothing. And I add another 1. I add another 1. Add another 1. That is not right. Okay. All right. I'm just saying I need to take it, right? I need to take it, which means line number 16, I'm gonna make some changes, right? Current range from this. So you cannot take it, right? You shouldn't take the current. Well, because this has to be true, right? This has to be true, so that's why I'm doing this. But also I'm gonna say if basically I'm taking the current, right? I'm taking the current. If I don't do the current, I do index plus 1. Right? I do index plus 1. Oh, that is fine because I think they all have it. They all have it, right? Because if I do this and I print, dp 0, let's say 10 -1 true. Yeah, 0 is included. So 1 is 2, which is 0, 1, and 10 is going to be 0, 1, 2, 3, 4, 2, 9. That's 10, and then 11. That should be 11. No, 1 to 10 is 10. It should be 11. Why do I have 12? Exactly. Why do you have 12? It's not supposed to be 12. It's not supposed to be 12. It's supposed to be 11 because I count 0, 1, 2, to 10. Right? That's 10. That's 11. It should give me 11, but I got 12. Okay. What do you think? Well, if you do 1, I got 2. That's right. But you do 10, so I have 1, 0. So the first one, I say no, I don't get. I want to do this towards the end, and you do this towards the end. You will start from -1. I say okay, I don't do it. So now I got a 1, and then your current digit is current digit is 0. And it's a starting. I think that was the problem, right? The current digit is 0 and you're starting with it. And the pre-digit is -1, right? Your current digit is 0 and the pre-digit is -1. Because you keep counting, right? The first one you count. Oh, hold a second. We can always choose not to start from the current index. Yeah, I agree. We can always choose not to start from the current index. I think it's the leading 0. I think that's the problem. Because this already handles with shrinking number of digits, right? The shrinking number of digits. Which also means I think I think yeah, the first one's fine, right? Just index plus 1. So we just say we'll find all the digits or everything within this number of digits, right? And then you can choose to set it to use the current or not use the current. And then we need to, what if the current is 0? Yeah, exactly. What if the current is 0? Well, if the current is a 0, which digit n is a 0, then I go through, and if I tell you it's not tight, right? If it's not tight, then yeah, you do whatever you want. If it is tight, yeah, then you cannot go above, right? If it's tight, then you cannot go above. Which means if pre-digit is -1 and index is equal to 0, but here index is not equal to 0, right? So, and it's not tight. So I can go through 1 to 9. Yes. Okay, yes. You go through 1 to 9. So I got 9 out of it. That's good, right? That's good. And then I have the first one, just go through everything. So I have 10, right? Else, oh, I have duplicate. No, I don't have duplicate because a pre is -1, right? I'm looking at here, pre is -1. That give us 9, right? That give us 9. Okay, and then everything go, that give us 10. So I handled everything starting from here, right? With it, and then we have to go back to here. So we go back to 1. Pre is -1 is a 0. Then I need to go from 1 to 1. That I don't go any of them because I cannot go above. Then I just do pre-digit is a 1, right? Pre-digit is 1, and I go to this position, okay? And it's tight, okay? It's tight. So now I come in, and I do. Oh, I think the duplicate is I do this all the time. I should only do this once, y'all. I should only do this once. Okay. Okay. You should only do this once. How? Well, I'll go through the whole thing, right? I do it once, and then. Okay, so I think what I'm saying is, oh, I think I probably have to do something like this. Count n and str, and then we'll return an integer. And then within this, lordy, within this we're gonna do this, okay? And then okay, so rest equal to 0. I'll handle whatever this needs to handle. Okay, and then at the end, so we don't change digits, but we change digit here, right? We can say res equal to for yeah, so res shall equal to dp index is 0, right? And all right, I don't need this one, right? This is not necessary. This is not necessary because it's already in it. So now what I'm gonna do is 0 pre is -1 is tied as true, okay? So that's the first one, and then I need to go, let's say for this in range, because I can start from index 1, so 1 towards len and str, right? I can go through all of them. I can go through this. I can say res plus equal to dp. Oh, actually I need this, right? dp from this I and -1 and then false, right? It's not tight. We go from I, and when it's not tight and predigit is -1 and index is not equal to 0, so we just go through everything, right? So we went through everything. That's the different number of digits. So this is find right, this is find stepping numbers of the same number of digits as NSTR, right? That's that. And then this is find stepping numbers of smaller, fewer, right? Fewer number of digits as NSTR. So we'll do both, then we'll return result. And let's just delete these. And we're not gonna do DP here. This is gonna be count, right? And just directly count high minus this is gonna be count. This, right? str and this and this. Okay. Not sure. This is gonna be right. Oh, do I have a test case here? I do. Sorry, and all of these NSTR need to be removed. Okay. Try it again. Oh, okay, this is correct. Let's try these. Ugh, damn it. All right. Let's see. Right, this is not right. Okay. Result 7. Answer is 6. Well, I mean, the best one is we're gonna print count high, just see how many did we count, and figure out if we can get actually count high, count low, right? It's fine. It's fine. I don't really care too much. So high is 20 and the low is 13. So what we're saying is high is what? High is 60, right? So we say 60 to give me 20, and 26 give me 13. Right? Okay. So things smaller than 26. I think I count the 0, right? So it will be 0 to 9, and then 10. That's it, right? That's it, 10. Because 1, you can do 1, 0. No, 1, 2. 1, 0, 1, 2. And that's it. 2, 2, 1. And 2, 3. Yeah. So that'll be 10, 11, 12, 13, 14. That's supposed to be 14. Okay, how about 60? Well, 60, we have 3, 3, 2, 3, 4, 4, 3, 4, 5, 5, 4, 5, 6, and that's it. You can now do 6, 5. So that's 14, 15, 16, 17, 18, 19, 20. So we have a little bit issue. I did not count 20, probably did not count 23. Okay, now let's debug. Let's debug this. All right, what do we need? We have, so 2, right? 2 comes in. I call this, start from 0, -1, true. So I have 2, right? And then it's this. So we say can now go beyond. Then I do 1, right? So I do basically, the previous digit is 1. So basically I do the 1 something. And this is a false, right? This is a false, not tight. And I also do the digit n, which is 2, right? So we do 2 something, which is true. Okay, so 1 something, which is false. So it comes in, it's a false. So predigit is not, -1 go here. Predigit is 1, smaller than 9. So I can say current digit is +1. So I can, this is actually go into 1, 2, right? 1, 2, and current digit is equal to, that's a false, right? So that's a false. Or I can do here, right? Predigit. So I do a 1, 0. So I do a 1, 0, which is a false. So both are false. Okay. So now we have a 2 comes in. And index is out. Index out because I'm already in the second position. So index out. So I count this, I count this. Perfect. And next one is 2. Okay, so we start with 2. Predigit is 2. All right, predigit is 2. And it's a true. Right, it's a true. And 2 is smaller than 9. Yes, so I can do a 3. Current digit is 3. All right. So current, the digit n shall be 6. So if not tight, it is tight, but this. So I shall be able to do current digit. That's a false. So I shall be able to get 2, 3. Right? I shall be able to get 2, 3. And of course, I also said predigit is 2 is larger than 0. So I shall be doing -1. So I shall be get a 2, 1 as well. I don't know. I don't know why. I got 4. Right? Oh, it's here. So I got this 4. It's this part, maybe. Maybe this part is wrong. The single digit. Now the single digit, I start with, you know what? The easiest way to find out is we're gonna print this one, right? We're gonna print this one. So I'm gonna print res, and we're gonna print dpi -1 false. Okay, we're gonna get a load to this. Ugh, why so many values? Oh, because, okay, that's fine, okay, so I need to just print count low. Alright, there's a count low. Why there's still so many? Oh, because that's, no, wait, it doesn't make any sense. I shall only print oh, I see why, because of this. I probably shouldn't do this then. And we'll print res. In fact, it'll be easier if I do, let's say, nstr, right? This is same digit, right? And then this we can say same thing, nstr index, right? And then we say nstr total. Okay, now we can take a closer look. All right, so 25. Oh, that's fine. 25, 26, same thing. Same digit as 4. Exactly, we got 4. And index, well, I do not need index. Hold on, that's not index. I just need this I, right? I. All right, so I is 1, I got 9. All right, that is the problem. That is the problem. I shall get 10. But then 60 has issues. Right? Because you can have 9, that's okay. But for 60, right, the 60, same digit, I got 11. That's not 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That was the issue. All right, that was the issue. Why is it 11? Exactly, why is it 11? Yeah, why is it 11? So we have, I do 6, right? If it's 6, then I have 1 through 6, right? 1 through 6. So if I come back here, if I handle 60, so at first, right, 0 minus 1, I go 0, and then the digit is 6. It's equal to 0, so we go here, and then 1 to 6, 1 to 5, right? We do 1 to 5, so we have 1 to 5. So I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These 10 we shall be able to get. Right? And the last I say res plus equal to this. 6. Right? Res plus equal to 6. So now the pre-digit is 6. Okay? And current digit is 0. So we come here. Pre-digit is 6. Okay, 6 is smaller than 9. So current I can do. Oh, I see. That is the bug. Right? It should be if. Oh, never be tight. Well, it's actually, we should do the same. If not is tight. Because now I have 6 is a 5. Right? It's a 5. Even though you decrease, you can still, yeah. Or current digit is smaller equal to digit n. Then I go here. Right? I go here. And I think this is still the same. We say current. Actually, depends, right? It depends. Because if previous is tight, right? If previous is tight, then here definitely is tight. So it will be, if previous is tight, then no, if previous is tight, hold a second. Now I'm adding, right? I'm adding. So if previous is tight, if it's not tight, it's just not tight, right? If previous is not tight, then you are not going to be tight. But if previous is tight, right? If previous is tight, so I think it's and. If previous is tight, then right now, if you are smaller than the digit n, so the next one can be not tight. So current digit equal to, right? If the previous is tight as false, so if previous is false, okay, so that I can agree to. And here I think is the same, right? So with this, and current digit equal to digit n. So again, if previous is not tight, then future will not be tight. If the previous is tight, right? If previous is tight, then if the previous is tight, and in my case, right, the previous is 6, it's tight, and the current is 5. 5 smaller or equal to 0, no, so we don't do it. But if it's the same, then the future will be tight as well. Can I combine these into one? Look at this. This is almost exactly the same, right? These are almost exact. The only difference is this. Huh. So what should I do? What can I do to make it? So I can say if this, I get a current digit. But there are 2 current digits, right? Two possibilities, right? 2 possibilities. I really don't like this. I think, if I can, because this is exactly the same code I repeated. All right, I repeated, and I hated it. Okay, I hate it. So, options. Okay, if this options.append pre-digit plus 1. Okay, and then we say if pre-digit is larger than 0, options.append pre-digit minus 1. Okay, so I don't need this. I know I have 2 options. And then for options in options. Or you can just say for current digit in OPS. Then I can do this, which means all these can be removed. All right. Okay, let's take a look. This one pass, but we have all these. Ugh. Let me comment out this and comment out this and comment out this. Let's run the test cases. Ugh, dude, what the hell? Now you pass the ones that used to fail. Now you fail the ones that used to pass. Boy, this is bonkers. How is that possible? Seriously, how is that possible? Oh, I see. This is wrong. All right, I don't do this anymore. No, I don't do this anymore. I don't know why you do it. No, you don't do this anymore. You already have the current digit, right? I already handled it. And then I just check. And then I go for it. Okay. So that was a typo. Now we pass. Okay. Do we have the confidence that this one will work? Yeah. We'll take a look. All right. So if this works, I'll be very happy. If not, we'll have to call it off today and then try it again tomorrow. Oh my goodness. I'm just going to... Oh. Yeah. Something is off. Damn, can I do a quick one? Like a quick debugging? Just here? Like say print, let me see, count high and count. Just copy this. All right, and just simple debugging. Let's see, what's the number I got? I got 10 and a 1. This 1, I agree. 11 should not be 10. Because 1... Oh, shoot. All right, feed the cat. What is the 10, 11, not 10? No, I think the problem is 0. 0. That was the problem. 0, the leading 0. It's because 11 does have 10. Right? 11 does have 10 because 11 you have 1 to 10. That's 10. The problem is the 0. I can just put 0. How can you avoid the 0? Because the 0 comes in, right? 0 comes in. That's previous is minus 1, right? So previous is minus 1. If the current value is 0, I mean the way I'm doing it. The way I am doing it, I probably can just use that as an edge case, right? The way I'm doing it, I can just use that as an edge case. Because it's not possible to have another case in the DP call with the first value being 0. It's not possible. I never use a 0. Right? If I never use a 0, that's not true. You do use a 0. Right? You do use a 0. The 0 is possible. But if you use a 0 along the way, oh, it depends. But whenever you become a 0, now it can be 0, right? And 0 is possible. What is bad is 0 with the leading is minus 1. That means it's a leading 0. That means that one should not count, right? That should not count. Okay, so that is what differentiates. Because the other zeros, if you do have a 0, like the current is a 0, you will not have a leading 0. You will only have leading you will not have minus 1 as a leading value. Okay. Alright. So I think what I will do is just set up that as a special case, an edge case. Okay, we'll do that as an edge case. Which means if if digit n is a 0 and pre-digit is -1, okay? So when that happens, we simply, because it's not going to happen in all the other cases. It's just not going to happen, right? It's not going to happen in all the other cases, because the only time that your pre-digit is -1 and the current digit is 0, the only time that that is possible is because all of these, the pre-digit is not going to be -1, right? These are not -1, so only these are -1. So when these are -1, when you handle it, these are not -1. Yeah, they're no longer -1. Look at this. They will never be -1. So when you call this function, except for the first call, none of these will be -1. And the -1 only happened here, right? It only happened here. And you happen here because you are trying to reduce the number of digits. And yeah, I think it's fine. I think what we need probably is just, the count function, right? I can just say if nstr is equal to 0, right? Then we simply return 0. What do you think? Not sure. We'll definitely pass these. And I think this wrong answer, yeah, I already tried this wrong answer, right? Oh, I know what to try. This, the best way. Let's put a bit more. Okay. And then have to be something bigger than this. Okay. Does this work? Looking good. Looking good. Okay, let's just do a lot of this and then make this one bigger. Okay. Does this work? I think it does. And I don't even need to print anymore. Right? Okay, let's try it. Try it. Oh yeah. Oh yeah, that works. Oh yes, it works. Yeah, it works. And it's not as fast as this one, for sure. But this one's way too complicated. It's a lot of things to consider. I mean, technically this one, there's a lot of things to consider as well, but overall, I'll say it's much easier to consider, right? It's much easier. All right, that will be it. Good. Solved it. All right, solved it. I probably, like, if I do the mod along the way, maybe it'll be even faster. Maybe. Are you curious? I am curious. 2, 3, 4, 5. Oh, 1, 2. 9 plus 7. All right, this is the mod. So we're gonna do the mod every single time whenever I have a plus equal to. So equal to res plus this, right? Mod is the same. Res plus this. We'll do a mod. Okay, and then it's the same. Res plus mod. And then blah blah blah. Res equal to res plus, and we'll mod. And oh my goodness, so many mod. And at the end, I mean, I read yesterday that if it's a negative, the model will still be correct. I'm not sure. I'm not sure. Is this gonna be faster? Nope. It's not faster. It's not. But it's okay. It's okay. So that's I think we can just, yeah. And not as fast, right? So we do, I don't even know the runtime. Well, runtime is, we definitely have to do 2 times, because it's tight, right? 2. Pre-digit is 10 options. Index, that's n. And then within them, I go through at least 1 round. Yeah, I think another 10. Shall do, have to do 1 round of this, or 1 round of this, or yeah, just 1 round of this. And we have this one that's like another 10. I'll just ignore it. Oh, that's an n, right? That's an n. Huh. I think we need to times another n, because you go n times and then you do this. Interesting. Well, I did do n times, but it's O(n) squared, right? Yeah, O(n) squared. O(n) squared. No, n times 2. N times 2. It's not O(n) squared. Anyway, I'll end it right here. I need to think about this time complexity. I mean, it's easier for this because they handled everything inside. For me, I have this part. I'm just kind of confused about this part. You do this n times, right? Within each, what do you say? Because for this, that's the DP, right? The time complexity of DP is this, for sure, right? Because you have this 3 states, right? That's n, that's 10, that's 2, right? That's that. And then within each, you'll run through it 10 times. Well, that's it. But for here, but this only runs once. So I intend to say we don't really care about this part. I think this is it. Yeah, seriously, I think this is it. Let's call 367. That doesn't really matter. 367, right? 367 milliseconds. Okay. All right, that's it. Good work. I'll see you guys tomorrow. Oh my god. All right, see you guys tomorrow. Adios.